Welcome to another lesson on conic sections. In the previous videos we've looked at circles and ellipses and hyperbolas, so now we're going to look at parabolas. So again, the idea of a parabola here is if you have a plane that intersects a cone where the plane is parallel to this the far edge of the cone, we get the cross section would cut out a parabola. So the things that we want to look at for a parabola, how do we sketch its graph? Same things we've done before. How do you draw the graph? How do you write the equation? And then what are its characteristics, things that we can identify. So for a parabola, it's a little different. We're going to have a vertex like we have before. We have one focus point. We have something called a directrix and then something called a focal diameter, and we'll look at those, what those are. So again, a definition similar to the other ones that we've had. A parabola is the set of all the points in the xy plane that are the same distance from a fixed point, which is our focus, and a fixed line, which is called the directrix. So again, just in a generic picture here, if I picked any point along the parabola, the distance from that point to the focus is equal to the distance from the same point down to this horizontal line, which this line is called the directrix. So the distance from the point to the directrix is equal to the distance from the point to the focus. So this line here and this line here are equal to each other. That also means, because if we move the point down to the vertex, it means the distance from the vertex to the focus has to be the same as the distance from the vertex to the directrix. So the vertex is right in the middle between the focus and the directrix. And if you want to explore this more, there's a couple little demonstrations that you can play around with. All right, just like with hyperbolas, we have two different versions of our equations for parabolas, whether it's horizontal or vertical. With vertical, parabolas are what we're most used to, and so in general, just think y equals x squared. Okay. So when we apply that to conic sections, we still have the y variable and we still have x that's being squared if it's vertical. But we have to figure out the h and the k. So in this case, h and k is not center. hk is your vertex, which should be similar to notation you would have seen back in algebra. So hk represents the vertex. P here, and you may see that as different letters in other texts, but P is the distance from the vertex to the focal point, and it's also the distance from the vertex to the directrix. So the total distance from the directrix to the focal point would be 2P. I didn't illustrate it here, but the focal diameter, which is the fourth thing that we need to know, the focal diameter would be the distance sort of across the parabola as it passes through the focal point. So if you drew an imaginary line across the parabola and it crosses through the focus, this distance here would be the focal diameter, and I'll illustrate that in some of the examples we look at. If we flip the parabola horizontally, so now it's opening left and right, this would be a y squared equation. And notice the 4p, so in both of these equations we have a 4p in front of y, or in this case a 4p in front of the x. Again, that p represents the distance from the vertex to the focus and also the distance from the vertex to the directrix. Notice if we have a vertical parabola, we have a horizontal directrix, and if we have a horizontal parabola, we have a vertical directrix, so they are perpendicular to each other. All right, so let's look at some examples. So here we have a graph, and we have a couple of points labeled. We have a vertex and a focus labeled. So from the graph, we should be able to identify the vertex, which in this case, that's -1, 5. And we should be able to identify the focus, which is at -1, 3. And notice that these are vertically aligned. They're on the same x value. we've already talked about, in order to write the equation, we need to find P, which we've already talked about. It's the distance from the vertex to the focus. So this distance is 2 units apart. And because the parabola opens down, I'm going to say P is actually a -2. So again, the parabola is a vertical parabola. Because it is vertical, that tells us what the equation is going to look like. It's going to have an x squared and then just a y. And so we know what h and k is already. We know h is -1. We know k is 5. So we're going to have x minus a -1, which becomes x plus 1 squared. We know the k is 5, so we have y minus 5 here. And since we already know p, we might as well plug it in there. We know p is a -2. So if we simplify that, we get x plus 1 squared is equal to -8 times y minus 5. And that would be the equation of our parabola. So let's look at another example. This time we're not given the focus. But we can still figure out information off the graph. So things we should be able to read off the graph. We still know where the vertex is, because in this case it's nice and easy to see. It passes right through 2, -1. We don't know the focus, which means if we don't know the focus or the directrix, we don't know P. I do know the graph opens to the left, which means it's a horizontal parabola, and that's going to be important here in a sec. And we can also pick another point from the graph. So in this case, an easy point would pick is one of the y-intercepts, so 0, 1. We could have also gone with 0, -3. So using that point and the vertex, we can go ahead and write out what an equation would look like. So just plugging in, again, because it's a horizontal graph, I know it's going to be y that's squared. So if I know and I know the vertex is 2, -1. So I can plug in a -1 for k and a 2 for the h. And so we get y plus 1 squared is equal to 4p times x minus 2. Now, we're not done. I need to figure out what p is. And again, we didn't know that because we didn't know the focus or the directrix. But we do have an equation here that has 3 variables. It still has an x and a y and a p. And I have a point on the graph which would represent the x and the y coordinate. So if I take that 0 and that 1 and I plug it in for the x and the y, we can then solve for p. So we plug in 1 for the y, 0 for the x, and we simplify, we solve down, we end up getting p is a -1/2. So that's what we're going to need that to finish our equation. And we can also use it to figure out our focus. The focus, remember, the focus point has to be inside the curve, so it has to be to the left of the vertex. It's not going to be out here on the outside of the curve. It's going to be inside it. That means the focus has to be a half of a unit to the left of our vertex. So what's half of a unit to the left? So that would be at 1.5, -1. So that's where our focus is. If the focus is on the inside, the directrix is on the outside, and it's going to be a vertical line this time. And it would be 1/2 of a unit to the right. So it would be here at 2.5. It would be a vertical line, x equals 2.5. To go ahead and finish our equation, though, we already had most of the equation down here on the left. We just had to plug in that -1/2 for p. So, and if we simplify the 4 and the -1/2, we get y plus 1 squared equals a -2 times x minus 2. All right, let's try another simpler one. Y squared equals 2x. So just from the equation, the things that we should be able to figure out is the vertex. So since there's no h and k, the vertex is 0, 0. To figure out p, we're going to look at the number in front of x. So this is 20. And in the generic formula, this is a 4p. So I know that 20 has to equal 4p. You divide by 4 and you get p is equal to 5. Okay. I also, because everything here is positive, I know it's gonna, and it's y squared, I know this graph has to open to the right. So it opens horizontally because it's y squared. It opens to the right because it's positive 20. Had this been a -20, it would have opened to the left. So from the information we have, we can find the focus, the directrix, and the focal diameter. So remember, the focus is 5 units away, because that's P. It's 5 units away from the vertex. Because the graph opens to the right, it has to be 5 units to the right. So 5 units to the right of 0, 0 is 5, 0. If the focus is 5 units to the right, then the directrix is 5 units to the left. So it's a vertical line at x equals -5. And then the focal diameter, I don't think I listed the formula out, but the focal diameter is the number that we're looking at. It's the 4p. So it's in this case, it would be 20. It'll always be positive too, because it's the distance. So in this case, the focal diameter is 20. So let's sketch our graph. We know the vertex is at the origin. It's at 0, 0. We know the focus is at 5, 0. We know the directrix is over here at a -5. Oops, I missed my negative, so x equals -5. And then the focal diameter. So the focal diameter would be if I drew sort of this imaginary line across the parabola through the focus. This distance has to be 20 units. The whole thing has to be 20 units long, which means half is, so the top half is 10 and the bottom half is 10. All right, if you want to practice a few in the lab manual, you can. And then before we get to our last two examples, again, let's just review our standard equation, our general equation for a conic section. We know that if the A and the C are equal to each other, we have a circle. We know if they are different but have the same sign, then we have an ellipse. If they are opposite sign, so if A is positive and C is negative, or vice versa, then we have a hyperbola. So now for a parabola. In order for us to have a parabola, you can only have one squared term. So either A is 0, and so there's no x term, it's just y squared, or the C is 0, which means the y squared term is gone, and so you're only having the x squared term. So you can only have one squared term, then you'll have a parabola. So let's look at a couple examples here. So x squared plus 6x minus 8y plus 17 is equal to 0. So we're going to do completing a square again for the x term. So let's group the x's on the left side and move everything else. So let's group the x's on the left side and move everything else to the right side. So on the left side, we're going to have x squared plus 6x plus whatever we add to complete the square. On the right side, we're going to have an 8y minus a 17 plus whatever we added on the left side. Half of the 6 is 3, and 3 squared is 9, so we're going to add a 9 to both sides of the equation. On the left side, that factors to be x plus 3 squared. On the right side, we get 8y minus 8, and then we can factor the 8 out, so we get x plus 3 squared equals 8 times y minus 1. So that's our standard equation there. From that equation, we should be able to figure out several things. We should be able to figure out that the vertex is at -3, 1. We should be able to figure out that the graph opens up. Okay, it's vertical because it's x squared, and because the 8 is positive, it opens up. Had 8 been negative, it would have opened down. Had it been the y that was squared, it would have been horizontal. Again, we know the 8 is, in our generic equation, the 8 is where the 4p is located. So that means 8 is equal to 4p, which means p has to equal 2. From that, once we know p in the vertex, we can find the focus, the directrix, and the focal diameter. So since the graph opens up, the focus has to be 2 units above the vertex. So it's going to be at -3, 3. The directrix has to be 2 units below the vertex. So in this case, it's going to be a horizontal line, y equals a -1. So -1 is 2 units below a +1. And then the focal diameter's length is 4p, which in this case, it's a length of 8. So it's against the 8 that's sitting out front here. All right, to draw a graph, we go 3 units over, 1 unit up. So there's our vertex. We know the focus is 3 units above that. 2 units above that. We know the directrix is 2 units below that. The directrix is a horizontal line. The focus is just a point. And then, again, this is not to scale, but the focal diameter. So the distance across the parabola here through the focus point should be 8 units long. All right, one more example here. We have, again, only one y squared term. There's no x squared, so I can just, looking at this, I can tell that this is going to be a parabola. So let's group our y's and move everything else over. So we have y squared plus 10y plus whatever we need to complete the square. It's going to equal a negative 2x minus 21 plus whatever we add. Half of 10 is 5, and 5 squared is 25, so we're adding a 25 to both sides. We factor the left, simplify the right, and then we factor out a negative 2. So y plus 5 squared equals a negative 2 times x minus 2. Again, from this equation, we should be able to figure out the vertex. It's 2, negative 5. It opens left, so it's a horizontal graph because it's y squared, and because it's a negative 2, it's to the left. The negative 2 also is the 4p, so p has to be a negative half. You just divide the 4 over. Once you get here, we can figure out the focus, directrix, and the diameter. So the focus has to be inside the parabola, so it is a half unit to the left of the vertex. So it's going to be at a 1/2, negative 5. The directrix is the opposite direction, so the directrix is going to be 1/2 to the right of 2, negative 5, which would be at 2.5. So it's a vertical line because this was a horizontal parabola, so vertical line, x equals 2.5. And the diameter, focal diameter, again the 4p, this number here is a negative 2, so we just knock off the 2, or the negative, so focal diameter will be a 2. Again, we sketch our graph. The vertex is 2, negative 5, so over 2, down 5. We know that the focus point has to be a half unit to the left of that, and the directrix has to be a half unit to the right of that. We know if this were the scale, this focal diameter here should be 2 units long.